Then the catch is weighed to 600 kilograms per crate, wheeled into a truck, and zipped to the processing plant. The fish won't stay alive, but they'll stay fresh for the journey to the plant. Andy and his team didn't fare as well as they would have liked, but Andy takes it in stride. There's always tomorrow.
We'll go slow and we'll work it all out one way or the other.
Yeah.
The Sea Wave is out night after night searching for a big catch, the mother lode. But catching fish in the wild is unpredictable, so some have looked for ways to eliminate the risk. We're just off the coast of Vancouver Island, above one of the many fish farms operated by Grieg Seafood, which is among the largest salmon farming ventures in the world. With a staff of 115, they operate 20 farms with 17 active sea-based sites safely tucked away from winter storms. The man in charge here is Blair Billard.
The West Coast can be a pretty rugged area in the wintertime, and you want to have a spot where it's sort of sheltered.
On-sea operations are basically a system of floating fish pens anchored to the sea floor. These coastal waters provide the perfect habitat to raise salmon. And if everything goes as planned, this will be their home until they reach 5 kilograms.
From the time they hit the sea till the time that they're harvested, roughly 2 years.
Farming salmon is very delicate work, so staff monitor the fish 24 hours a day, 7 days a week, year-round. The only way to do this is by actually living on site, on this barge.
This barge itself is a floating concrete structure. It's 110 feet by 60 feet. It's concrete, but it has styrofoam flotation underneath.
On the main floor of the barge is the feed storage area, and not far away is the feed control room. They're running a state-of-the-art generator-powered centralized feeding system. With the click of a mouse, they can release feed to the 600,000 fish on site.
Right now we're feeding approximately 5 to 6 tons a day on this site.
Blair's crew moves up to 100 of these bags a week to keep the silos supplied.
Okay, so here we are now underneath the silo system. This silo here and this silo here both have augers which spin and deliver feed and drop the feed down into what we call the sluice box.
From there, the feed goes through a series of tubes and is propelled out of this swirling pipe. Feeding these fish is a science, and the most important decisions are made in the lab.
Before we feed every day, we want to make sure that the environmentals are okay. So a typical day in the life of a salmon farmer would be to get up in the morning and check the water quality. So every single morning, faithfully, we check the dissolved oxygen levels in the water.
Not enough oxygen in the water can spell disaster for the salmon. They won't be able to metabolize their food. This leads to one thing: death. Blair and his team can't control oxygen levels because a lot of it depends on Mother Nature. But what they can control is the feed. So when oxygen levels are low, they starve the fish. This way, the fish don't burn energy processing food and are able to survive. This is Grieg's newest construction project, a brand new fish farm called Conception Point. Building a new site is complex, but professionals like the ones on Blair's team can assemble one in 10 days. To do this, they start by finding the perfect location. They map the seafloor to determine where the anchors should be placed to hold down the pen. The next step is building the gigantic steel skeleton that holds these 14 net pens together. It's a huge puzzle that covers an area of 13,000 square meters, the size of almost 2 football fields. Today, it's time to install the most important parts, the nets.
What they're doing here now is they pick up the net, they'll take each corner individually, and with the capstan on this boat, they'll pull each corner out to where it belongs to make it fully square.
These nets are super strength and built to last. It would take over 180 kilograms of pressure to break one. The last critical step is to secure each net to the seafloor with 5 2-ton anchor blocks. With a price tag of $35,000, each nylon net weighs about 2 metric tons, and each will contain more than 40,000 young salmon.
So in addition to the nets that we have for fighting the sea lions and seals, we also put top nets over our cages to prevent birds from getting into the pens.
But all these nets can't protect Blair's fish from his biggest enemy, killer plankton.
Our #1 challenge up to this point has been fighting plankton blooms.
Many types of plankton grow naturally in seawater, but one type is deadly to fish. It's called heterosigma. Although this kind of plankton poses no threat to humans, it can have dire consequences on a fish farm.
Yeah, it could kill an entire farm.
And with each farm site growing more than 600,000 salmon, worth millions of dollars, this could put any farm operation in the red, if not cause it to go under. In the summer season, when the water warms up, it changes color. Heterosigma multiplies so quickly and becomes so dense, the water literally turns red. Killer plankton produces a toxin which is harmless in small amounts, but deadly if the number of heterosigma cells reaches a count of 500 per milliliter of water. The search to find the exact cause of death is ongoing, but one theory is that in high concentration, the toxin interferes with oxygen uptake in the gills of the fish. The fish's defense mechanism produces mucus around the gills, and the fish can't breathe. Blair can't destroy the heterosigma plankton, but he can minimize the fish's exposure to it. The plankton's distinct color can be spotted from the air, so from the skies, Blair can watch the plankton developing and track any progress toward the farm sites.
And we'll land on it and take water samples.
Blair casts a plankton toe in the water. This device, although quite low-tech, is the best tool to give Blair a precise concentration of plankton.
So this is a nice concentrated sample.
The sample is then taken to his lab to be tested.
He'll then count how many of those cells are in the water per milliliter.
If the algae bloom is too large, he resorts to his secret weapon. Its official name is the algae bloom mitigation equipment, but everyone at Grieg calls it the bubble wall. To contain the microscopic killer plankton, Blair and his team installed pipes around the perimeter of each pen, drilled holes in them, and connected them to large compressors. As plankton approaches, it gets trapped in the bubble wall and carried to the surface. Blair took the bubble wall idea one step further by adding a central diffuser. The central diffuser creates a plume that is strong enough to push water from the center and over the top of the bubble wall, away from the pen and the fish.
It worked quite nicely.
In the fish industry, it's all about getting the fish from the ocean to your plate in the least time possible to keep it fresh. But what if you could keep the fish alive during transport? That's what the Sterling Carrier does. This state-of-the-art live haul vessel was built to transport up to 100 metric tons of live fish per trip. They do pickups and drop-offs from fish farms to the Englewood processing plant in Port McNeill on Vancouver Island. Meet Captain Jeff Turpin. With over 35 years of experience under his belt, he knows that fresh means fast.
The object is to get the fish to market in the best possible condition.
Jeff runs a tight ship. The salmon delivery he's making to the processing plant has been planned for days, so he needs to show up on time. Once the Sterling carrier arrives at the fish farm, it's time to harvest. This ship is capable of loading and unloading 70,000 kilograms of fish per hour. And it does that without harming the fish.
We like to say they're usually in better shape when we drop them off than they are when we get them.
The salmon will go from these fish pens into these huge holds in less than 1 hour, thanks to a new generation pumping system. This is Ted Kennedy, one of the Sterling carrier's owners.
Right now you're looking down into one of the port fish hold. This pipe is where it comes through the loading system and through the main deck down, and it puts the fish into the hose.
The best part is that the fish will never be out of water. They fill the holds with 650 cubic meters of water before sucking the fish in with the pipes. High up in his captain's chair, Jeff is getting ready to start loading.
Okay, now we're going to put this loading hose in the water. Okay, so now I'm going to drop it down.
With the loading hose in the fish pen and the holds filled with water, everything is in place to suck the fish on board. Jeff now turns on powerful pumps that push the water out of the holds back into the ocean. This creates a vacuum suction inside the holds, and as the seawater is pumped out, the water containing the fish rushes in to fill its place. Just like a huge vacuum cleaner. The process is monitored with this computer. On their way to the holds, the salmon pass in front of a camera, and an imaging program counts the fish and calculates their volume and weight. Jeff carefully adjusts the valves, increasing the velocity of the siphon. The rate of the upload is speeding up.
The fish speed now is about 3.8 to 4.2 meters per second. So if I increase the pumps, I can increase the speed of the fish coming on board.
All this happens pretty quickly, uploading about 17,000 salmon an hour.
Plus I could get a printout, everybody gets a copy, everybody's happy.
The work here is done, so the crew prepares the ship for the trip to the processing plant. To keep the salmon comfortable during the 2-hour voyage, each hold is equipped with 7 hydraulically controlled valves, flushing 400,000 liters of fresh seawater through the holds every 10 minutes. Jeff monitors the oxygen level in the holds. If the levels are too low, he will supplement it with oxygen from these tanks to keep the fish healthy.
I can manipulate this figure to whatever I want so that the fish are kept at a comfortable oxygen level. Then I do that by adjusting the flow controllers here.
This ship is so advanced it could almost run itself. But just in case, they keep engineer Corey Olson on board at all times. He can troubleshoot any technical problem, lightning fast. The Sterling carrier has a single propeller powered by a main engine that churns out 1,000 horsepower. And it's loud.
It's a little quieter in here. You heard me.
These 2 generators are for the electrical system. They power the pumps and the blowers that get the fish in and out of the holds. After a couple of hours of smooth sailing, the Sterling carrier pulls up to the processing plant.